How's it going, everybody? In this video, we're going to go ahead and take a look at our next topic, which is VPC and VXLAN. Now, normally I would have recorded a video specifically on VPC that isn't tied to VXLAN, but so it is. But we're going to be taking a look at how VXLAN and VPC integrate with each other. Now, the actual solution that they call this is called AnyCast VTEP, where the VPC peers are actually going to be able to send data over the VPC down to the member switch that we're going to be peering to, and it doesn't matter which particular device the communication comes in on. If it comes in on one VPC peer or the other, they're both going to be able to respond to it. And this is going to take a little bit of configuration to get it working, and there's some anybody that follows me on Twitter already knows the struggles that I went through to get this to work. So that's kind of where we're at with that. So one of the things that we're going to be taking a look at in the configuration is setting up VPC. It's not terribly difficult to do, but there are some kind of gotchas, if you will, in order to make it work the way that you need to, in order for it to work the way you need it to. So with that being said, the VPC is virtual port channel. Now, I'm sure you've heard of port channel on a regular catalyst switch, where you take two physical links and you bundle them together, and then you allow the port channel hashing algorithm determine which particular member interface you send traffic out of, right? Well, that's all well and great, but at the end of the day, what we're trying to achieve here is more than just load balancing, right? We're trying to achieve high availability. So for those of you that have ever heard of Stackwise or have ever heard of virtual switching system, this is along those same lines. Let me go ahead and switch over to my topology, and let me kind of go into some of the more kind of the meat and taters of what I mean by this. Let me go ahead and actually let's minimize these real quick, and I'll do a little bit of whiteboarding to try to illustrate what's happening here. So essentially what's happening with VPC is in Stackwise, I'll put in here SW for Stackwise, you would take a couple of switches, right? A couple of pizza box little 1U switches. These could be any model campus layer access switch, and they would run what they call a Stackwise cable between them and plug them into these Stackwise ports. What ends up happening is this little guy right here becomes a backplane extender. So it basically interconnects both switches, and they, instead of looking like two physical line cards, 1 and 2, it looks like, so instead of being two physically different switches, you make two switches look like two line card switch. So it looks something more like this. And then you have a little in here, a little separator. You have line card 1, line card 2. Now, on a bigger chassis-based model, like a 6500 or 4500X or something along those lines, what you would do is you would have the chassis itself, which is a, if you're not familiar with blade servers, they work in the same sense. You would take and you would have the very top of this would be broken up into two things, and you'd have SUP 1, supervisor engine 1, you'd have SUP 2 over here. So you'd have redundant supervisor engines, and then you'd have line cards that would get plugged into them, right? So you'd have line card 1, line card 2, line card 3, so on and so forth. Well, you deploy two of these, right? You'd have your supervisor engines here at the top, then you'd have your line cards, something like this, right? Well, what you would do from supervisor engine to supervisor engine, you would connect this one to this one and this one to this one. This would be a bundle called the virtual switch link. This is where all of your communication would go back and forth over. And then these two boxes would look like this. Just like that. Be a single upstream switch from the downstream devices that you're peering to, right? So it doesn't give you more line cards, it just gives you more port density. So what essentially is going to end up happening here is this is physical, this is logical look, right? So, and then this one here is physical, this one over here is logical. VPC works in very much the same way that VSS does, or virtual switching system. This is VSS. VPC does something very similar to that, except for it takes it a step further. I have my line card right here, and I have my line card right here. This could be a couple of Nexus 5Ks or a single U Nexus switch. And what you do is you run a cable between these guys, and this cable right here is called the VPC Peer Keep Alive. This is run in its own dedicated VRF, or virtual routing and forwarding table, which we talked about in the previous video. We're going to be creating another one called VPC. And what you do is you give this an IP address, and this was 9K1, this is 9K3. You're going to give this the 10.1.3.0/24 subnet. You go through all that. What's going to end up happening is this is going to be the control plane, right? This is going to be all control plane propagating MAC addresses and routing table information, all that good stuff. You're going to run a couple of cables from one to the other, and this is going to be known as the peer link. The peer link is a interconnection between the two switches in the event that traffic needs to come in from here and travel over the VPC peer link and then down to a member device. That's what the peer link is there to do. What the VPC is basically going to do is it's going to take individual ports, could be one, could be more, and you're going to run these downstream to some sort of member switch. And you're going to configure this port here and this port here to be in a port channel. It could be on, it could be LACP, it could be anything in between. The bottom line here is it should be a trunk if it's going to connect down to another switch. It should be access if it's going to connect down to a server, stuff like that. But what you basically are going to do is you're going to configure this port right here to be a trunk and a port channel, this port right here to be a port and a trunk, or a trunk and a port channel. And what you're going to do is you're going to go to the port channel level on the 9Ks up here, so port channel, let's say 10 for example, and you would type in VPC 10. And by doing that, you're actually going to tell the switch that these two VPC peers are going to look more like this to the downstream switch. It's going to look just like that. And so you're going to have your VPC switch, you're going to have your member switch down here. And that's where really the beauty of how all this stuff comes into play and works. So as we start diving into the config, it's going to be a little tricky to get it working out of the gate, but once you go through the steps of setting it up, you're in pretty good shape. Now the reason why this is called AnyCast VTEP. So let's write that down, AnyCast VTEP. What that basically means is that whatever interface you're using to associate to the VTEP, this could be loopback 0, it could be loopback 100, it doesn't matter. Whatever loopback address you're using, or loopback interface, excuse me, you're using to associate to the VTEP as a next top IP address for VXLAN or for BGP updates, things like that. Underneath that interface, whatever loopback address it happens to be, you need to configure on both of your VPC peers underneath that interface the same IP address. So in our case here, we're going to use 10.0.0.13/32, and we're going to set this up as a secondary address. It'll get advertised into OSPF and be reachable in the underlay. So definitely something important to keep in play and in mind. And when we do that, we're going to flap our NVE interface and get the updates, and that's going to allow any of the other connections to realize where the traffic is coming from. And that's really the beauty of how this whole solution comes into play and works. It really needs to be understood in that method. So that's basically where we are in terms of the operations. So with that being said, let's go ahead and take a look at how this actually works and go from there. We go ahead and clear the screen and jump into the CLI. So I've got the peer keep alive identified as 1/3, and then we got 4 and 5 as the peer link. So on switch 1, we're going to go up here and we're going to type in, the command is going to be feature VPC, and then on 9K3 we're going to type in the command feature is going to be LACP as well as VPC, because right now only 9K1 has the LACP feature cable turned on. So feature VPC. Now that we have that going for us, I'm going to go back to 9K1. I'm going to type in VRF context. It's going to be VPC. And I don't need to do anything else besides that. I'm going to go configure interface E1/3. We're going to type in switch port. Or sorry, no switch port. It brought down the... That's weird. Show run interface NVE1. Interesting. Okay, well, give that a couple seconds to do its thing, but once that converts to no switch port, we'll be able to, there it goes. We're going to type in VRF member is going to be VPC, and the IP address here will be 10.1.3.1//24, and no shut it. Do the same thing on 9K3. We're going to type in interface E1/3. We're going to type in no switch port. And then we're going to type in VRF member VPC. The IP address will be... Oh, we have to create the VRF first. So VRF context VPC. Interface E1/3. There we go. And then IP address here will be 10.1.3.3/24 and no shut. Alright, now that that's done, we're going to go ahead to the next level and we're going to go create our VPC domain. So back on 9K1, I'm going to go ahead and say VPC domain 13. And then we're going to have to set up our VPC peer keep alive. Our peer keep alive. We're going to say destination is going to be 10.1.3.3 with a source of 10.1.3.1 and VRF VPC. Okay, that's that. Next thing, we're going to do the same thing on 9K3. So I'm going to pretty much do this line for line. VPC domain is going to be 13. Peer keep alive will be destination will be 10.1.3.1. Source will be 10.1.3.3. VRF VPC, just like that. And the next thing we need to go do is do a show VPC, and we can see that the peer is alive, which means that we have reachability to the other side. I'm going to go ahead and type in interface E1/4 to 5. Type in switch port. We're going to type in switch port mode of trunk, and we're going to type in channel group 13 mode of active. And then we're going to go ahead and go to 9K3, same thing here. We'll type in interface E1/4 to 5. Type in switch port mode of trunk, and then channel group 13 mode of active. Now that that's going for us, we're going to jump over here and type in interface port channel 13 and type in VPC peer link. Do the same thing over on 9K3. And because of the fact that spanning tree port type network wasn't applied, I went ahead and added it. We're going to type in interface port channel 13 VPC peer link. Just like that. Now that with that is set, we need to go and do a show VPC again, and we're going to see that it looks like everything is squared away, considering we've tried to make everything as close to possible as we can. So everything's looking pretty good. So it says peer adjacency has formed, peer is alive, configuration consistency failed. So if we do a show VPC consistency parameters and hit the enter or global, we're going to see what we missed. So everything's looking pretty good for everything we've done. The problem that we have, and it actually tells us what the problem is right here. It says that that the secondary IP address does not match, and that's referencing that loopback 0 secondary IP that I was just mentioning, because we have this matches, everything's looking pretty good, and we're in good shape there. So I can type underneath VPC domain. I can go to VPC domain 13 and type underneath here. I can say that the role is going to be priority, and we can see what the priority value is. So show VPC, and I can see that we look at the details here. We can see role. We can see that I'm secondary, and I can bump this one to be higher, and I believe it's a lower value wins. Let me go ahead and set that though. So the VPC, the role will be priority, and I'll put this to a lower value. I'll put this down to a value of 1. So it says VPCs will be flapped on current primary VPC switch while attempting option 2. So show VPC, and if we go to the, in order to flap it, it means to go, we can either shut it down, right? We can shut it down and then no shut it, and it's going to detect that the pure keep alive failed. Show VPC now, and so we're still primary, but we're still primary, and eventually the active VLANs will show up, and now we're secondary, which means now 9K3 will be our primary. And I want it to be primary, but hit the up arrow and do a show VPC. We're going to see that we're primary, and the reason why I want it to be primary is because we already have 9K1 terminating VLAN 210 and VLAN 220. So I wanted it to flip over to be this guy to be primary, so that when 210 and 220 for 17 and 19 came online, they're going to point to this guy right here. So traffic will actually point to 9K3 to get to where they've got to go. With that being said, it gives us a little bit of diversity considering how the current design is set up. The thing that I need to go do now, if we were to go to E16 on both sides, so let's go to interface E1/6, type in switch port, we're going to no shut it, type in switch port, mode of trunk, and then I'm going to come down here and type in channel group, and I'm going to give this channel group 10 mode of active. Okay, same thing on, and then what I'm going to go do is I'll type in interface port channel 10 VPC 10. Something very, very simple like that. I'm going to go over to 9K1, and I'm going to go to interface E1/6, switch port, and no shut it, switch port mode of trunk, and then I'm going to specify channel group 10 mode of active. Give that a couple of seconds to create the port channel, and the interface port channel 10, I'm going to type in VPC 10. Now that I've got that in play, the VPC will actually fail. And let me go down to switch 8 and do this config real quick. So if we go on here, we do host name is going to be switch 8. We're going to type in interface range gig 0/0 through 1. I'm going to shut down the links. Give that a couple seconds to register. And I'm going to say switch port trunk and cap.1q, switch port mode of trunk. And I'm going to type in channel protocol is LACP. The channel group will be 1 mode active. I'm going to go ahead and no shut the connection, and it's going to come online. But it's not going to work quite right. So we'll see line protocol come online, the port channel will come online, but we're going to have problems. Port channel 1 is online. If we do a do show ether channel summary, we're going to, in this case here, it's working the way that it's supposed to be on this side, which is good. But on the VPC on this side, if we do a show VPC, we're going to be failed, giving us all kinds of problems. Same thing over here, show VPC. And when I hit this brick wall, I hit it hard. And I was like, I don't understand why it's failing. When literally, the configuration is telling me right there, secondary IP address does not match. But I didn't know what that meant. So to fix this, we have to go to interface loopback 0 and say IP address of 10.0.0.13/32 secondary. And then do the same thing over on 9K1. Interface loopback 0. IP address here will be 10.0.0.13/32 secondary. And then interface NVE1, we're going to go ahead and shut. and then we're going to go ahead and no shut to trigger the update. Interface NVE1, shut, and then no shut. And then on switch 8, we should see that's looking pretty good. Go back over to Nexus 9K1, show VPC, and after a short period of time, that should come online. We have an invalid aggregation port bandwidth error. Not sure what that, so that's interesting. So, and now we have the port channel is up because we made sure to get everything squared away that it needs to be, and we're good to go. So on switch 8, I'm going to go down here to do a do show interface trunk. See the port channel is there. Do show VLAN brief. No VLANs are created. So I need to go say VLAN 210, name VLAN 210, and VLAN 220, name VLAN 220, and then I'm going to do interface gig0/2, switch port access VLAN 210, switch port mode of access, spanning tree port type or port fast, and then interface gig0/3, switch port mode of access, switch port access VLAN 220, and then spanning tree port fast. Just like that. All right, now with that in play and everything's good to go, the next thing for me to go do is test PC17 and PC19. So PC17, go ahead and pull him up real quick. And we're going to go ahead and put him right there. And then PC19 right there. So rename him to PC17 and rename this guy to PC19. On this guy here, we'll say IP will be 10.1 or sorry 10.2.10.17/24 and 10.2.10.254. And on this one here, we'll say IP of 10.2.20.19/24 to 10.2.20.254. All right, now that that's done and we have everything squared away, I should be able to ping back and forth, right? So let's ping our gateway, 10.2.20.254. Make sure I can ping that, which I can. I'm going to go ahead and ping 10.2.10.254, which I can. Now the question is, can I ping between the two? Ping 10.2.20.2.19. You bet your bottom dollar I can ping. I have inter-VNI routing squared away. So that's basically where that comes into play. So if I come back up here and I do a show BGP, L2VPN, EVPN, and I look for VNI 20010, I should see 15 and 17 showing up, right? And I can see that my source IP address is 10.0.0.13. That's because I have the secondary IP address set. I do the same thing from 20,020. I have the same thing. 16 and 19 are now reachable from the same VPC peer. And that, ladies and gentlemen, is everything that we needed to cover in this particular scenario. And that's what I really wanted to make sure that I covered in this video, was how to set the VPC up and all that good stuff. So we are in good shape in this particular setup so far. So that's as far as I'm going to take it in this video. There are going to be some other some follow-on videos we're going to dive into. We're going to set up a VPC between the 5K and 6K, get him completely online, and then we're going to go ahead and get switch 6 online, get the firewall going, and go from there. So until next time, guys, thanks so much for stopping by and hanging out with me in this video, and I'll see all of you in the next video.